Okay, so today I want to talk to you about throwing away files and getting away with it. What are even files? But first, I'd like to thank the Patreon supporters. I really appreciate the support. If you'd like to help the project, you can always go to patreon.com/dscf. I appreciate every pledge. Now, moving on to the main issue. So why do we even want to get rid of files in the first place? As you know, in the past 40 years or so, especially in the Unix tradition, everything wants to be a file, or at least some hybrid. In Windows not so much, but you get what I'm talking about. Files are really good because they offer portability, at least some degree of portability, and they rely on cache for speed. But there is something that really nags you, and that is that the files are not quite real. I mean, not in the your eyes are not real sense of real, but in the hardware sense of real. The access time when you implement files on your own is really slow, and if you want to do bare metal, you will realize that libraries are often not optimal. So if you take away the modern computer, which is billions of times faster than what used to be 10 years ago, you can see that files are not quite what they are painted to be. In contrast, us for programmers, we use blocks. Blocks partitions the memory directly into 1024 bytes or whatever block size the underlying hardware supports. They offer immediate access as long as they are stored in RAM, and well, they are very easy to implement. You can implement blocks over the internet, you can implement blocks directly talking to the hard drive or the SD card, and they are directly loaded into memory at boot time, so they are always there when you need them. They can store code and they can store data. But as always, there's a catch. Blocks are pretty much a bespoke solution to a problem, so it's not a general solution, as there are times when you need more space, less space. You can always partition it in 1024 bytes, especially when you're dealing with data. So how can we even interface with the outside world? If the blocks are a bespoke solution, they are not really all that portable. You have your own implementation, I have my own. So I did this by implementing ROM, that is loading file into blocks. So I'm going to show you how in less than 10 lines, or about 10 I'd say, we can get rid of files and implement a ROM loading mechanism. It's really easy and it works really well. So let's start. Okay, so starting right away, let's start with defining a word called ROM, and I'm going to put some comments and I will link it to the app block. And when you call ROM, you will get this 0 on the stack. So let's just test it out, and let me get rid of the clear here. So if I test it out, I get a 0 on the stack. You can see it down here in the left part of the screen. So this is the main address of our ROM file. Now let's get the memory organization laid out first. So first I'm going to have a signature called AA, BB, CC, and DD. This is a signature in hex, is a single word that is 4 bytes. Then we're going to have a name, which is going to be 16 bytes. Then a length of the total file, which is going to be 4 bytes, that is just a word. And finally we're going to have the data. You can see where this is going. We're going to check if the signature is valid, then check if the name matches whatever we want the reference to. Then we get the length to see how long it is, and if the name didn't match, then we are going to just jump over this data here. So first I want to make a word for loading the ROM, so I'm going to call it load ROM, and load ROM will take a string or a data word, and I'm going to fetch the data register, the compiling register. I'm going to AND it with -4. That will align it to the word boundary. Then I'm going to add 4 to that, and I'm going to store it back into the B register. Then I'm going to fetch it again. I'm going to swap it with the data on top of the stack, and I'm going to load that data into memory. Now we have the remainder, we have this add B on the stack, and I want to store that into the ROM variable. So if I test it out, let's see, load ROM, I'm going to load data.res, I make it a data word, I tag it as immediate, I tag the load ROM as immediate, and let's see if it doesn't crash. It's okay. I call ROM, and let's see, we have here in the stack the value of the ROM address. So okay, now that we have a way to load the ROM data into memory, we want to have a word to check that memory and search it for the data that we want. So I'm going to make a word called ROM, which will take a data word, and I'm going to take that data word and store it into the 16 string memory. If you look at the source, you can see that 16 string is just a simple way to store some character data into a specific memory filled with zeros. This makes comparison a breeze. Now we follow that up by putting the ROM address on the stack and pushing it into the A register. Now I'm going to define another word in red called loop, which will be the starting point of the search. Now the A register is pointing right here into this signature here, so all I have to do is fetch the A register and increase it by 4 and compare it to the signature itself, AA, BB, CC, and DD. I compare it, and if it's equal, then we'll do it means it's valid, and we'll do the search. If it's not valid because the signature is not equal, then we will start doing our error handling here. So I will begin by making a display here with the question bracket. I will put the 0 color, which is the red color, and I will say ROM error in as a string, which I will print. Then I will get the 16 string memory. If you look at the source, it's just 16 bytes, and I will print that as well. I will close the display, and I will jump into code by effectively resetting the machine after you press a key. When it says oh, I didn't found this and that, it will give you this error. Now let's handle the actual search. So if the search is valid, the signature is valid, you will see that the register A is now pointing at the name, which is 16 bytes. So all we have to do is fetch A and do a 16 compare. You check out the 16 compare, and it's just the 16 memory, and it compares 16 bytes. If the comparison is valid, then it will return a 0. If it's not valid, it will return a number larger than 0. So if the comparison is valid, we have to jump, and if the comparison is not valid, then that means I'm sorry, it's in reverse. If the comparison is not valid, we have to do the loop, and if the comparison is valid, that means we found our data. So we have to get the register A, and we have to add 20 to it, because the name is 16 bytes and the length is 4. So if you add 20, you will be pointing directly into data. I duplicate that and I subtract 4 and fetch that. That will leave us with the address and the length of the data. So load rom, rom here will return the address and account. Okay, then all is left to do is pop the register A and return, or well, that return is already handled here. So okay, now we have to go back and do the loop. So we didn't find anything, we have to point right to the next signature. So it makes sense to do this thing again. We add 20, we get the data and we get the length. You add it to the register A, and now you're pointing right next to the next signature. So I think it's good to have this word refactored into its own word. So let's see, rom data, and I'll put rom data here, and that will be that, and I will put rom data here. I will add it and I will store that into register A. Finally, I will get that loop and convert it into a jump. And let's see, let's test it out. Let's say data.res. I will do that as an immediate, and I will load that ROM. Let's see, everything is working. Then I will get Patreon, I think it was the image, and I will search for that ROM. So let's press F5, and you can see that it's valid, it found something. Now let's say if I do something that it is not found, it will say ROM error, iPad something can be found. Okay, now I have a demo for you a little bit later, so let's see it in action. But first I like to have the final word, which is just compile ROM. So I will search for the ROM, I will swap, I will say lit and then lit. So whenever you have a word and you want the resource for that ROM address, you can do the following. Let's say test, and I will say Patreon bitmap, and I will say compile ROM, and whenever I call test, it will crash. And I realized that it was because I wasn't even loading the ROM. So load ROM data.res, and let's see, and now it works. So well, maybe I should have something here, so maybe like dup, and if it's 0 I'll have an error. Let's see if I can do this quickly. Let's see, no ROM, let's see, and I'll say ROM error, not ROM. And now if I remove this from here, they say error, not ROM. Okay, no ROM. And this is a little bit of error handling, although I don't really use it in my own code. Okay, so now right before the demo, I think we should address the elephant in the room, and that is, how do you even get this file, the data.res file, into the fourth language? So what you do is you use this little tool I wrote in C. It's called the resource packer, or respack for short, and you call it in the command line. You give it the address of the folder, the name of the folder, and it will generate this data.res file that you can load, you can share, and you can even put source code in that as if it were the resource packet data like you used to see in games back then. So let me show you the source code for the resource packer. This will be included in the 1.1 release I'm working on. So it's about, let's see, about 63 lines of C, and you can see the irony is that you need 63 lines to deal with the directories and to get rid of the file structure, but you only need what, like 8 lines, 1 2 3 4 5 6 7 8 lines of code to deal with files in Forth, and that will find the file for you and tell you if it exists or not. Now back here in Forth, you've seen already a demo. It's this Patreon screen. If I turn on the blue words, you will see the word path here. If I select it, that means if it's not executing, you will see that the path word disappears the background here. So if I go and look at the source, you will see that some code to put the image on screen, and the name of the resource, and bg, which will just generate the word, the path word here. So of course this is still in a beta stage. I am still ordering things and setting things up for the final release, but you get what I mean. Now I'd like to show you a little something I made. It's a little demo. It's a little bit more convoluted, but you know, I like the tapestry style of things, so here it is. I've been comparing this language to the monolithic architecture that people sometimes find. I find the subject very interesting, and let's say that if you or I were to carve this something like this into stone to draw future generations, they might unearth it thousands of years into the future and think it's some sort of alien language or something like that. It's just hilarious. But you know, you and I know the meaning of the monolith, right? So I'll see you next time.